Okay, now see this structure here. So what is the formula for acceleration I have given you now? Net pulling force divided by total mass being pulled. What is the pulling force? What is responsible for pulling both the blocks? M1G, not M2G, because it is not opposing or supporting in this case. So in the numerator, you will only have M1G divided by total mass being pulled. What is the total mass? M1 is pulled. M2 is also being pulled, correct or not? So what is the total mass being pulled? M1 plus M2. So what is acceleration expression going to be? M1G, which is the pulling force, divided by M1 plus M2. You can see the expression. If you see now, for body A, if I draw the free body diagram, M1G is in the downward direction, tension is in the upward direction, but resultant is in the downward direction. The body is moving down. So M1G minus tension equal to M1A. First equation. In case of second equation, for this block, what is the acceleration of this one? A. Listen, everybody. What is the acceleration of this block? What is the acceleration of this block? A, because they are all in one system. There's a fundamental of laws of motion chapter. All particles must have the same axis, so don't wonder. So what is the acceleration of this? A. What is the acceleration of this? A. So what is the equation? M1G minus T is equal to M1A. In this case, tension is acting in this direction. The surface is smooth, so no friction. So will there be any opposing force in the opposite direction? No. So tension 2, T2 will be, T is equal to M2 into A. That's the equation 2. So when you solve these two equations, you get, I told you acceleration, right? What do you get? Net pulling force, M1G. Total mass being pulled, M1 plus M2. Tension, if you see, it is half of what you got in the previous case. The previous case you got, listen, don't interact. 2 M1 M2 into G by M1 plus M2 you got in the previous case. This case it is half of it. M1 M2 G by M1 plus M2. Okay. Now see here. Now what are you having? Not one pulley. What are you having? Two pulleys. There is a mass in between. Now tell me, students, all of them are having the same acceleration, correct? Now just write the free body diagram and the equations for all the three. Solving, don't worry. Can you tell me for this M1, what will be the equation? M1G minus tension T1 will be equal to what? M1A, not A. M1A, force. M1G minus T1 is equal to M1A. Clear? For this body, can you guys tell me? Which is greater, tension 2 or M2? Because it's moving the other way, right? So what will be the equation? T2 minus M2G will be equal to what? M2A. T2 minus M2G is equal to, because net force is equal to what? Mass into acceleration. Okay, for body C, tell me this one. Very simple. Tension 1 is acting in this direction, tension 2 in this direction. Result is in this direction. So what is it? T1 minus T2 is equal to MA. That's it, guys. Don't worry about solving the equation. You can try it later. When you solve it, you are going to get this result. If you want to make a note of it, just note it. Then we'll move on. Okay, students, now let us move on. Okay, now going forward, we'll be seeing 2-3 examples. In all of them, we don't have to get to the final result, but at least frame the equations. Okay, when two masses M1 and M2 are hanging as shown in the figure. This is very, very important, students. Okay. Now see here, I shouldn't have written this here, but I have written, but you should know. Whenever a mass is on an inclined plane, you know that M1G acts in which direction? Vertically down direction. The component of that which is along the inclined plane is what? M1G sin theta. What will be perpendicular to the plane? M1G cos theta. Okay, that you should be keeping in mind. So M1G sin theta and tension are in which direction? What is the direction of M1G sin theta and T? Opposite. So acceleration will be in this direction. Let's say M2 is more than M1. So acceleration will be in this direction. So come on, tell me, students, what will be the equation for M2? Come on, tell me. M2G and tension is acting in upward direction. Which is more? M2G is more because the body is going to come down. Because M2 is more than M1. So M2G minus tension is equal to M2A. Okay. Is it clear? M2G minus tension is equal to M2A. Can you guys tell me for this one? Which is greater, T or M1G sin theta? T, because it's going up, right? So tension minus M1G sin theta will be equal to M1 into A. That's it. Look at the equations now. So for this mass, it is T minus M1G sin theta equal to M1A. For the other block, it is M2G minus tension equal to M2A. When you solve this, you're going to get the expression for acceleration and tension. So this is the final solved result. And reaction force on the pulley is the one which is acting in the upward direction. That you will get it as 2t cos 90 minus theta by 2. Just make a note of these results, but you don't have to derive them right now. But as long as you're able to frame the equation, that's good. I'll give you a minute, write down the equation. And also write down the results quickly. Then we'll move forward. As long as you're able to write the equation without any difficulty, you're ready. Don't worry about the results. Results, you derive it once, okay? I wanted to frame the equations. That should be good. Now tell me, students, just frame the equations. Very, very simple. All the blocks have, both the blocks have what? What is same for both the blocks? Acceleration is same. Very good. Now, for M1, can you tell me the equation, students? Let's say M1 is greater than M2, so the block will be coming like this. Can you tell me the equation now? I hope I don't need to explain again M1G sin alpha, right? Okay, M1G sin alpha is acting in this direction, tension opposite, acceleration is downwards. So write the equation. M1G sin alpha minus T is equal to M1 into A. That's it. For this one, can you tell me? M2G sin beta minus. Is it M2G sin beta minus T or T minus? T minus, because that is greater because the body is moving up. So come on, tell me. T minus M2G sin beta is equal to what? M2A. Very good. That's enough strings. Okay. Now, what is this? Very, very simple. Pulling force, net pulling force by total mass. What is the total mass being pulled? M1 plus M2. What is the pulling force? Mass into acceleration. What is mass? M1 into G sin alpha. What is the pulling mass here? M2 into G sin alpha, sin beta. But is this opposing it or supporting it? Opposing, so minus. So M1 into G sin alpha minus M2 into G sin beta. G you're taking out over. Net pulling force by total mass being pulled. That's tension you will be only able to do after you drive it. Okay. So don't worry about that. Or you can understand it in another way. If you remember, for the case where pulley has two strings perpendicular, angle alpha and beta will be 90 degrees. You got 2 M1 M2 by M1 plus M2 into G. Here also alpha and beta, if they become 90, what is sin 90? 1. 1 plus 1, 2. You will get the same expression. And reaction force, sine of alpha plus beta by 2. This also don't worry about it. Once you solve it, you will get it. But getting the equation is important. Okay, guys. This whoever answers this question correctly, I am going to give you a chocolate. It is very simple. Okay. If all of you answer, everybody, I'll give you 2 chocolates. I have enough stock. Okay, Mark. Tell me the answer and give me explanation. Both. You don't have to think much. With simple logic, you can answer, but you should be able to justify what would be the answer. Little trigonometry is required, little geometry is required. That's it. Last 10 seconds. 10, 9, 8, 7. Huh? Yes, yes, yes. I count once again. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, guys. So answer is 0, guys. I'll tell you how. What do you want to say? Can you tell me why it is 0? Okay, you just put the equation. Very good. Okay, guys. Yes, yes, use. Yes, use equation. Excellent. Excellent. Very good. Okay, I want to do it in a different way. Okay. Of course, you can use equation. What he has done? Net pulling force, right? What he has done is 4, right? 4 into G. What is it? 40. 40 in this direction. Minus. What is the force here, guys? M2 into G into sin alpha, correct? So what is M2? 8. G is what? 10. 80 into sin 30. What is sin 30? 1 by 2. 80 into 1 by 2 is what? 40. 40 minus 40 is what? Yeah. One more round of applause to you now. Excellent answer. Excellent. He has gone by the formula. He did not even remember the formula. He created it, right? He has understood the concept. So that's fantastic. Okay, now I will tell you an alternate method. Shall I? Are you ready? Okay. Here, little bit of trigonometry, little bit of geometry. That's all. Now, what I am thinking is, this block, whatever force it is giving, suppose if this was here, what will be the mass? This block which is like inclined, right? The same block, if it was perpendicular, then what will be the corresponding mass? That's what I'm going to analyze. Okay. Now see here. If this angle is 30, what is that angle, students? What is that angle? 60 degrees, right? Because overall angle has to be 180. So that will be 60. What is the mass of this object? 8, correct or not? That 8, I can resolve it into two components. One horizontal and one vertical. The horizontal component will not contribute to pulling force. The vertical component will contribute. So what will be the vertical component, students? Come on, tell me. Is it cos or sine? Cos, very good. How much? 8 cos 60. What is cos 60? 1 by 2. What is 8 into 1 by 2? 8 into 1 by 2, 4. So 4 kg on one side, 4 kg on another side. What will be the acceleration? See. Of course, right? I will definitely recommend the way Enoch has done for you guys, because this is probably, at this moment, probably out of the box for you, but this is more kind of thinkable, right? What Enoch has done. Right? He has done 4 into G minus 8 into sine theta into G, correct? That's more straightforward for you because we have given a formula for that. Okay, excellent. Anyways, we'll move on. Okay, sir. Now, this again we know apparent weight on a lift or elevator. We are just going to review this, students. Okay, a man of mass m is inside the elevator. Elevator is accelerating up with an acceleration a. Then can you tell me what is his apparent weight? N is equal to? Suppose, yes. So, what is it going to be? M into G plus A. Suppose if you add the lift mass and also the mass of the man, then the overall tension on that string which is pulling the lift itself will be what? M plus M. Lift's weight plus the man's weight. So, M plus M into G plus A. Clear? So, apparent weight on the man will be what? M into G plus A. Very good. Tension in the cable, that is this cable. That will be what? Mass of the elevator plus mass of the man into what? G plus. That's what this all we have seen already. When the elevator is moving downwards, you know that, right? What is the effective acceleration? G minus A. So on the man, what will be the apparent weight? M into G minus A. On the rope, what will be? M plus M into G minus A. So I'm not spending much time on this. Okay, guys? Already discussed. Now, same effect is felt when the elevator goes up with a retardation. I asked that question as a googly question. When it goes down with an acceleration, it's same as what going up with a retardation. Same effect will be seen. So as it was told, right? A is to be substituted as minus G in that case. If the elevator falls freely, what will happen? A will be G. Therefore, G minus G will become 0. This also we have discussed. These are possible, 1 mark questions. Okay, elevator moves up or down with uniform velocity. Then there will be no apparent change in weight. Normal reaction will be equal to what? Mg. Why? Because uniform velocity means acceleration is 0. So N will be equal to Mg. Tension in the cable will be what? Only G into this. Okay, quick. The lift is going up with uniform velocity. When brakes are applied, it slows down. In that lift, what will he experience? Quick. Sorry? Move weight. See here, he's going up. He's going up. When he's going up, you're supposed to have acceleration as what? G plus A, correct or not? So he should experience more weight, correct? But what is happening is it slows down. Brakes are applied. So negative acceleration. Therefore, he won't feel more weight, but opposite. Googly question. Less weight. Okay, next question. A man drops an apple in the lift. what will happen if you drop the apple? You will expect it to hit the floor, correct or not? But in this case, what is happening? The apple does not fall. What is it? What is happening? It's stationary somewhere mid in the air. Then what is possible? How is it possible? What is happening to the lift? You should tell me. Yes, tell me what is happening. Yes, going down with constant acceleration. Because when it's going down with constant acceleration, there will be an experience of weightlessness, correct or not? Of course, that experience is not so much for the man who is standing inside, but for the weight of the apple, it's absolutely weightless. Is that clear? That's the experience it is having. Or in other words, if you want to understand from the concept of pseudo force, do you understand that when the car is moving this side, pendulum moves back? So when the lift is going down, the apple, which was supposed to come down, what is the force it's experiencing? Upward thrust. Is that clear? So that's the reason that upward force, that is the pseudo force, is going to balance your mg. Okay, great. Tension in a string supporting bob. This is what we were discussing. This is also something which we have discussed. So we'll move a little fast. A bob of mass m is suspended by a string. Then we know that if a bob is simply suspended, what is the weight on it? Mg downwards. What is acting upwards? Tension. And both are balanced. So mg is equal to t. But when the bob is pulled up with acceleration a, which means the bob is inside an elevator and it's moving with acceleration a, then what will be the tension, students? M into g plus a. When the elevator is going down with the bob with acceleration a, m into g minus a. Is that clear to you? Okay, when the bob is pulled up or pulled down with constant velocity, no change. So t is equal to mg. When the bob is falling freely, then what will happen? T will be equal to 0, weightlessness. Because g minus a becomes equal to acceleration due to gravity. So it will become 0. Did you understand? When bob is falling freely, which happens when it's inside the elevator and the elevator is falling freely, what will happen, students? The effective tension is what? M into g minus a, but a is g. Therefore, g minus g will become 0. So tension is 0. Tension is not mg. Tension is 0 because it's falling freely. When bob is suspended, it's moving horizontally with an acceleration a. Okay, this also I'll give you chocolate. I hope it doesn't give you the answer immediately. Okay, it's not giving. I'm happy. Okay, thank God. Whoever gives me the answer, I'll give you 2 chocolates. Now, I will tell you, students, what is happening. I'll help you with the answer. Okay, yes? Okay, now tell me, what are the forces acting? Mg acting downwards, tension is acting upwards, and there is also what? An acceleration in the horizontal direction, isn't it? Now, if you see, the bob is, it's moving horizontally, right? So what is there? That A is there. And what else is there? Acceleration due to gravity is there downwards. So how many accelerations are acting on it? 2 accelerations. One is along the horizontal, another is along the vertical. So now tell me the resultant of the 2. That's the answer. You're talking about the angle. Can I have a magnitude? Tell me the magnitude of the vector, resultant of the vector. Simple. You have learned it in your motion in a plane. How do you add 2 vectors, students? Using what? Parallelogram of vectors. Can anybody tell me the expression for R? Who can tell me? Raise your hand. Yes, go ahead. Very good. You have got backwards. The resultant of two vectors is equal to root of p square plus q square plus 2pq cos theta. In this case, what is theta? Anybody? 90. So cos 90 will be 0. So what is the root of p square plus q square? One vector is a tangential, another vector is what? Vertical. A tangential is a vertical is g. So what is the answer? Root of a square plus g square. That's the answer. Okay. So tension will be equal to mass into effective acceleration. Effective acceleration will be what? Root of g square plus a square, because g is acting vertically down, a is acting on the horizontal. Vector addition. Okay, ma. Quick review of linear momentum. We are going to enter into something which is extremely important for your PU upcoming exam. Could be a 5-marker possible. Linear momentum. What is linear momentum? Already seen. Linear momentum is the quantity which is going to tell you about the complete motion of the particle. What is linear momentum? Mass into velocity. We are going to use this in collision. I'm going to show this diagram once again. And you know that mass is a scalar, v is a vector, momentum is a vector. All this we have learned. We are moving forward. Linear momentum is a vector quantity, the same direction as what? Velocity. Unit of linear momentum. Come on. Kilogram meter per second. In CGS system, what is it? Gram centimeter per second. Or it can also be written as what? Or Newton second in SI. Okay. Now we are going to talk about collisions. So two bodies are moving with, let's say two bodies represent a system. One body is of mass m1, another body is of mass m2. m1 and m2 are having velocities u1 and u2 respectively. And they are going to go and collide with each other. After collision, they are going to change their velocities to v1 and v2. The total momentum remains conserved. Total momentum remains. The momentum of individual bodies is changing. Body 1, it had m1, u1 earlier. Now it became what? m1, v1. Momentum I'm talking about. The body B, what it had? m1, u2. m2, u2, I'm sorry. Now it became what? m2, v2. Velocity change. But system, if you see, as a system of both these objects, the momentum is conserved. We are going to prove that. It's a possible 5-mark question for your quarterly exam. Okay, ma'am. Now tell me. Change in momentum is always calculated as final momentum minus initial momentum. If there is a m missing here, it's mass into final velocity minus initial velocity. As momentum is a vector, vector subtraction must be used in finding the change in momentum. All this we already know. Okay. What is linear momentum? A product of mass and velocity. Very good. What is the dimension formula for linear momentum? m(t power -1. Very good. Now this is very, 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 very important. Not only for your quarterly, even for your board. Not only for your board, but also to understand your next chapter. You will use it in next year also. Everywhere. Law of conservation of linear momentum. Okay. Very, very simple. We know that whenever there is no external force, that is how you should start. Whenever there is no external force acting on the system, dash remains constant. Momentum remains constant. Velocity also remains constant. Okay. But here we are talking about momentum. Momentum remains constant because Newton's second law says what? F is equal to dP by dt. When P is constant, differentiation of P becomes what? 0. So force is 0. So external force is 0, then momentum is constant. Very important. In the absence of external force, linear momentum of a body remains constant. This is your first statement when you're asked this question. So if F is 0, P is constant. But linear momenta is the plural of momentum. linear momentum of individual particles can change, but the total linear momentum of the whole system remains constant. Is it clear to you? If I consider two bodies which are comprising, now the system is comprising of these two particles. Initially, they have masses m1 and m2. Their initial velocities are u1 and u2. They are moving. They collide. Because of collision impact, their velocities change from, for mass 1, it changes from u1 to v1. For mass 2, it changes from what? u2 to v2. So individually, the velocities have changed. Individually, the momenta also have changed. But overall system, if you take for both the particles together, the momentum is constant. Whatever momentum was there before, now also same momentum will be there. That's what we are going to prove. Now we'll see examples, couple of examples. In fact, you will understand law of conservation of linear momentum is just an implication of third law. Notice third law. Recoiling of a gun, right? When the bullet moves forward, the gun moves little back, right? Because before shooting, the gun and the bullet, the velocities were what? 0. Momentum was 0. So when the bullet is moving forward, the gun is moving back. But not to the same extent, correct? Bullet is probably traveling a couple of kilometers, but the gun is only moving probably a few centimeters, correct or not? Why? Because velocity is not constant. Momentum is, you understand, momentum is conserved, not velocity of individual bodies. Momentum, if you calculate, bullet size is small, mass is small, velocity is large. Gun, mass is big, velocity is less. That's why it moves little bit. Clear? In the opposite direction. Do you remember one guy running from the boat and jumping in my first slide? Example for law of conservation of linear momentum. Earlier, the boat and the man was at rest. Then the man ran and he jumped. So the man moved this side, the boat moved back. According to conservation, now we are coming into the proof, guys, very important. According to conservation of linear momentum, what is it? M1 plus M2 is equal to M1 V1 plus M2 V2 is equal to 0. We are talking about recoiling of gun. Similarly, in an explosion, what happens from? Let's say a bomb is there. All the particles which are there inside the bomb, what is their velocities inside? What is their momentum, initial momentum? 0. When it is blasting, what should be the total sum of all the momentums? 0 only. That is why if one particle goes like this, another particle will go in the opposite direction. If you add vectorially all the mass into velocity of the particles, it will be equal to 0. So if the shell at rest breaks into 3 fragments, the total momentum of any 2 fragments must be equal and opposite to the momentum of the third fragment, which means if you add the momentum, algebraic sum of all the momentum should be equal to 0. Direction wise, if you want to talk about 2 of them, if you add, it should be equal and opposite to the third one. It is from vectors. I will give you one explanation for that so that you can understand this better, this statement. Suppose if there is a shell or a bomb which blasts, one particle is moving in this direction, another particle is moving in this direction. Can you find out the momentum with the direction of the other particle? Very much possible. What you should do is you should complete the parallelogram. Where will be the resultant? Where will be the resultant of P1 and P2? Along the diagonal. Very good. Third part, where it should have gone? It should have gone in the direction opposite to the resultant of these two. That means this resultant is moving in which direction, students? Along this diagonal, correct? In this direction. So the third momentum must be in which direction? opposite to that. So that will be moving like that. This is what is conveyed in this paragraph. If a shell breaks into 3 fragments, the total momentum of any 2 fragments must be equal and opposite to the momentum of the third fragment. Let's move on. So that's why P1 plus P2 must be equal to minus P3. Or in other words, P1 vector plus P2 vector plus P3 vector will be equal to 0. Now proof. This is where all your attention must be, okay? For your scoring perspective, I'm saying. Let M1 and M2 be masses of 2 bodies A and B moving in the same direction along a straight line with velocity U11, U2. When they collide with each other, let's say body A is moving with velocity V1, U1, body B is moving with velocity U2. This is before collision. Now both the bodies are colliding. This is after collision. Is that clear? Are you understanding? So this is both the bodies moving before collision. This is the collision. This is after collision. So after collision, what has changed? Masses are same, but what has changed? Velocities have changed. Individual momentum has changed, correct or not? But if you add the total momentum of this, that will be equal to what? Total momentum of this, it will be equal to total momentum of this. That is the proof. Let's write it down. Initial momentum of A, let it be M1 U1, you will call it as PA. Initial momentum of B, let it be PB, M2 U2. Final momentum of A is PA dash, which is M1 V1. Final momentum of B, P1B dash or PB dash, M2 into final velocity. Now, we will introduce the concept of impulse. What is impulse, students? Force into time. So, when ball A is hitting ball B, correct? Or object A is hitting object B, it provides an impulse to B, correct? What is that impulse? Impulse results in, impulse is nothing but what? Force from A on B for a time, delta T. And that will be change in momentum of this body, correct or not? So let's see here. The force applied on A by B in time T is nothing but it will result in the change in momentum of A. This is how you must write in the exam. So from Newton's second law, we know that force is nothing but change in momentum by time. So change in momentum is force into time. So what is FAB, guys? Force on A because of B. The ball B is hitting ball A. So the force on A because of B for a time T is equal to final momentum of A minus initial momentum of A. Change in momentum. Now, similarly, when the hitting is happening, not only that B is imparting force on A, but according to Newton's third law, what is it? A will impart equal and opposite force on B. So we'll see that. To take down quickly this. Okay, now next. See here. Yes. Okay, initial momentum M1 U1, initial momentum of B M2 U2, final momentum of A M1 V1, final momentum of B M2 V2. The force applied on A by B will result in change in momentum of A. So P1 PA dash minus PA is FAB into delta T. Just don't write every statement, students, just write the terms. That's enough. How do you see, ma'am? Everybody is taking notes. I told one statement. What did I tell, ma'am? Important 5-mark question immediately. I think that is what you are waiting for, huh? Only important, huh? Okay. Now I see everybody writing down. Sir, please wait, sir. Huh? Okay. Let's move on, students. Okay, students. There is one meeting now. We will do one thing, okay? Okay, students. So we may need to conclude here at this point, okay? Anyways, we will continue on Monday. I have already sent you one notes to you guys, right? Through Father has sent you yesterday. That will be very useful for you. Secondly, one more notes will be sent today, which will have questions and answers. That also can be helpful for your preparations. Okay, see you all the best. We'll continue on Monday.